And for our final video, it's time now to set up the system of equations. I keep saying this, but it's very important to remember. All of the previous steps have led up to this point. We've tried to reduce the total number of equations that we had by reducing the number of variables and unknowns. We've done so, and now the only option we have is to set up a system of equations. We'll find actually in this case that we're going to get one equation with one unknown, but the steps are all the same. I'm often asked, which method should I be using? The answer, almost always, is nodal analysis. Nodal is general. In this course, it will work for any circuit. Sometimes, nodal analysis isn't enough. You may need to use, for example, the relationship between voltages and currents in dependent sources in order to get an extra equation. But nodal is always a starting point. In general, what you want to do is create a nodal set of equations. We could have started with this step first, but then we would have had essentially 6 unknowns. Why 6 and not 12 that we should have had? If you've been following the videos, you know that I would need a current and a voltage through all of the 6 resistors. However, nodal analysis relates the current and voltages together, so really we'd only have 6 equations. Even so, that is very large. Typically, we're not going to solve that by hand, and that's why we went through the process. So let's begin using nodal analysis. I'm going to redraw the circuit, and I'm going to identify 2 important nodes. That's a 1 amp source, and remember, all the resistors are 1 ohm. Now, I need 2 important nodes. The first one is my reference, and I'm choosing the bottom node as my reference. Sometimes the bottom node won't be a natural reference, but the reason I'm choosing it here is because many components connect here. Essentially, this is the node with the most common connections. In this particular case, that's going to simplify things. The next question I have to ask myself is, which nodes do I really need to consider as unknowns? If this is a 10 volt source, then I already know what that node is. It's 10 volts with respect to my reference. Because we've figured out the voltages here and here, I know the voltage of that node. I don't need to consider it. If you're wondering, it was 5 volts. I don't know the voltage at this node, so I will need to consider that, and I'll label it VA. I also don't know the voltage at this node. However, I'm not going to need it. The reason is because I do know the current flowing in this branch is 1 amp. Since nodal analysis requires me to relate currents and voltages, if I already know the current flowing through the branch the node is a part of, I don't need to worry about its voltage. My next step is to label some currents. That's 1 amp, as we've said. That I'll have to call I2. There's I3. Through this resistor, I4. And through this resistor, I5. Notice how what I've essentially done is chosen my own directions for those currents. Here's how I did that, although it's not really a general rule. The 1 amp current I know the direction of. I know it's going that way. I2 and I3, to me, makes more sense for them both to be leaving the node. I could be wrong in that assumption. The reason it makes more sense is because I have a voltage downwards to ground through that resistor. I3 is a little more complicated, and I just had to choose a direction, so I chose outwards. I4 and I5 similarly. I had to choose a direction. For I4, it made more sense because I had a voltage going downwards to ground. For I5, I really don't know what the polarity is. But again, I just like to choose going outwards if I can. You may choose something different, and that's okay. My next step is to write specific equations for each of these currents in terms of the unknown voltage. I'll begin with I2. I2 is VA over R2, but R2 is 1 ohm, so I2 is VA. For I3, I have a problem. I only have a wire, so I don't know what the current through it is. I'm going to have to use the fact that I3 entering at this node is then split into I4 and I5. I3 then is I4 plus I5. I4 is VA over its resistor, but that resistor is 1, so it's VA. And I5, I need to be careful. I need to remember that I chose a particular direction. I'm moving from the VA node through the resistor to the 10 volt ohm load. Therefore, I5 is VA, because that's where I'm starting from, minus 10 divided by the resistor, which is 1. These are the equations. But really, I'm just using Ohm's law. I haven't used nodal analysis yet. Remember that nodal analysis is the continued application of KCL. In this case, I only need to apply it once, because I only have one node. And I'm going to write it as follows. Considering this node here, 1 amp in is equal to I2 plus I3. However, I3 was I4 plus I5. So 1 amp in is I2 plus I4 plus I5. Substituting now, I2 is VA, I4 is VA, I5 is VA minus 10. If I solve this, VA is going to be 11 over 3. Believe it or not, I'm now done. I know all of the voltages across my resistors, and through that, I can use Ohm's law. Now, let's see what those voltages are, because the voltage across one of those resistors is actually backwards. VR2 and VR3 are the same, because they are in parallel. These are equal to VA, which we know is 11 over 3 volts. I got a positive number out, which means I chose the polarity correctly. VR4, though, is not. I have VA minus 10, or 11 over 3 minus 30 over 3, which gives me negative 19 over 3 volts. I could leave it in as a negative, but typically we prefer positives. So what does this mean? If this is R4, the polarity that I assumed had the positive here and the negative there. Remember, this is going to the 10 volt source. However, I ended up with negative 19 over 3 volts. I'd like to make everything positive, so I have to flip the sign here and switch the directions. So it turns out that R4's voltage is actually plus minus in that order, and now it's positive 19 over 3 volts. I now know all of the voltages across all of the resistors. That can now lead me to using Ohm's law to get all the currents. Let's recap. We began by inspection. What this was a listing of what we know without computation. Inspection is a very important step. If you don't do it, You may not be able to tell yourself what you do know, and you might think you have more variables than you actually do. The next step is we use series and parallel. This reduces the number of unknowns and equates them. We then used physical laws. Remember, that was things like Ohm's law, voltage dividers, current dividers, and in this case I only use KCL, but you could use KVL as well. This allowed me to solve for as many unknowns as possible and to set up a system of equations. Finally, we solved. I've already said this, but at all times our goal was to reduce the number of unknowns and get the smallest system, which means the fewest unknowns per equation that we can. We use nodal analysis because nodal is a general technique, much more so than mesh analysis. In general, whenever you're setting up your system of equations, nodal should be your starting point. And that completes the video series. I hope it was useful to you. If you follow these steps, you'll be surprised at how much more organized your problem solving can be. Thank you.